All right. Hello at home, everybody. This is Miss Sinclair. It is March 18th, so it's Thursday. All of your friends at school say hi. Hi. We miss you. I think you guys are starting to come back next week. So here's what I want to tell you guys at home. Tomorrow's the last day of the marking period, so there will not be a new lesson tomorrow. We will be doing lesson 20 today, and we'll finish lesson 20 tomorrow. Put that away. All right. So in the last couple of days, we did this activity where we talked about a girl and her sister, and how they were 2 years apart. And you'd either +2 or -2 to get the right ages. Today we're going to do something similar, but we're going to do multiply and divide instead of add and subtract. So I want to show you what that looks like. And we're going to practice this together today and tomorrow both. So there's a farmer's market that's selling bags of apples. Whoops. And in every bag there are 3 apples. So if you look at the table, one bag would have 3 apples, 2 bags would have how many apples, Dominic?
6.
And 3 bags would have how many apples, Olivia? And 4 bags would have how many apples, Brooklyn?
12.
All right. So we're going to stop right there, and we're going to look for the pattern. Now remember, the patterns are going across the row. So let's see if we can figure out what we did to go from 1 to 3, 2 to 6, 3 to 9, and 4 to 12. What did we do, Mariana? We did what? We are counting by threes. We're actually multiplying by 3. So here's what I want you to put in this table. We're going to do it differently than we did yesterday. Put 3s all the way down the row. We're not going to put times 3. We're just going to put 3 by itself. So put your 3s in there. And this is what I wanted to show you. If you know how many bags of apples, you times by 3 to get a bigger number. Because there's always going to be more apples than bags, because a bag has 3 apples. So this will always be the small number. This will always be the big number. Does that make sense? So if we go this way, we're going to multiply by 3. If I go the opposite way, and I start with the big number, and I go to the smaller number, I have to do the opposite of multiply, which would be what, Derek? Huh? Divide by 3. So let's see if that also works. 3 divided by 3 is 1. Is that true? 6 divided by 3 is 2. 9 divided by 3. So it works, right? So a lot of times this is what I hear you guys say. I got multiplication, but I don't get division. I want to show you something. For those of you that think that way sometimes. It's the same 3 numbers. Times, answer, time, or divide, it's the same 3 numbers. So 2, 3, and 6 are always going to fit together. And 3, 4, and 12 are always going to fit together. So if you're dividing 12 and 4, what's the missing number? It's 3. 12, 3, and 4. So start thinking about it that way. Here's what we're going to do next. Now it says, what if we don't know the number of bags? But I know every bag there has 3 apples in it. What would I write here, Brooklyn? It's okay. Peyton. You're very close. You're very close, but in algebra, we don't write it like that. Remember how we write it in algebra, Mariana? It's not plus. It's 3b. Watch, just like that. Remember when a number and a letter sit next to each other and there's no sign in between, it means multiply?
Yeah.
And the number's always first and the letter's always second. And there's no X anymore. Does that sound right? Okay, what if the market had 25 bags of apples to sell? What if this number was a 25? How do I figure out how many apples that is altogether? What did I do in all of my other patterns? I took the number of bags times 3. So Ethan, what would I do here? Here's the number of bags. How did I go from 1 up to 3? We multiplied, right? 2 times 3, 3 times 3, 4 times 3, B times 3, 25 times 3. How many apples would that be, Ethan? Think about quarters. You're counting by quarters. 75 apples. Exactly right. So if I start with a smaller number and I end up with a bigger number, that means I'm multiplying. What if I start out with the number of apples and I want to know how many bags there are? I'm not multiplying, I'm going the opposite direction. So what am I doing? What's the opposite of multiply? Divide. So I'm going to take the number of apples and divide by how many apples are in each bag? We're going to divide by 3. So you're either times by 3 or divide by 3. Any questions about that? Down here it says, now I found out 600 apples. Check this out. You ready? This number turns into a 600. I have 600 apples. Divide by 3. You remember the easy way to do this one? Aiden, I know I gave you a highlighter now because that's what you did with the last one I gave you. You stuck it in your hair just like that. So don't lose that one, okay? All right, so here's the easy way. 6 divided by 3. What's the missing number? 6, 3, and 2. And then you got to add the zeros. So I have 200. It will take 200 bags. How is part D different than part B? Well, let's go see. What did we do in part B? Peyton? Multiplied by 3 here, and what did we do here? Peyton? We divided by 3. So here's what you're paying attention to. Depending on if you're going from small to big, you're multiplying. If you're going from big to small, you're going to divide by whatever number we put in the middle. Does that make sense? Okay, let's look at page 2. Here it says in New York State, there's a 5-cent deposit on carbonated beverages, cans, and bottles. So in our state, it's not 5 cents. So let's make it be about our state. Let's see how we do bottles and cans. Ready? So I'm going to change New York to Michigan. And how much do we have to pay for a deposit for bottles and cans? Caleb?
That would be $1, and I can answer all the questions.
No, you can't answer all the questions, but it's not $1 a can. Think about it. How much do you get when you take the cans back to the store and you put them in the little machine?
I've only done
Each
bottles.
can, Peyton, 10 cents. So here's my next question. I'm going to have to use a calculator to do some of this. How do I write 10 cents? The way I would type it into a calculator. Derek?
0.1.
So let me show you an example. If I said $5.10, you see this part right here is the 10 cents, right? Does that make sense?
Yeah.
One container, one can times 10 cents equals 10 cents, right? One can, 10 cents. What about 2 cans? Ethan? 20 cents. What about 3 cans, Ethan?
30.
Write this down, Ashlyn. What about 4 cans, Ethan?
40.
Okay, see this number in the middle? We're going to put it all the way down the whole table. And we're going to check and see if that works, if that actually makes the right amount of sense. So 2 cans is 20 cents, 2 times 10 cents is 20, 3 times 10 cents is 30, 4 times 10 cents is 40, right? Caleb, do you have a question?
I already went through did all of
Okay, you didn't follow directions then. So you need to stick with the group, okay? So I want you to do it when we do it. Caleb, it's not what I asked you though. Okay, 10 cans. Anybody want to give me a guess, James?
10. $1.
10 dimes would be $1, right? Anybody want to guess? What about 50 cans? Caden?
$5.
$5. What about 100 cans? Ethan?
$10.
$10. Now, before we answer this next one, I want you to think carefully. Every time we went this way, we did multiply, right? So how do I write C times 10 cents? Omari,
C10.
you're really, really, really close. I like that you didn't say time, so we're not using an X, right? But there's one little tweak we got to change on that. Dominic, what is it?
8.
No, there's no 8.
I'm at 0. C.
Exactly right. See, Omari, what you did? You should put the C in the front instead of the back. Remember when we write that, we always put like 2B, the number's always first, and the letter's always second. So this up here is going to be 10 cents C. Omari, Ashley, you're not watching what we're doing at all. Okay, now we're going to use this equation to figure out how much money Brett would get if he got 222 cans. So get your highlighter out. 222 cans. So in this case, watch what happens. I didn't ask a question, Caleb. In this case, watch what happens. I'm going to take this equation and I'm going to write it down here, and I'm going to replace the number of cans with that number. Now, am I going to put an X in there I didn't ask a question, please, Caleb. Am I going to put an X in there to show multiply? No, I'm not. How do I show that I'm multiplying those two numbers, Caleb?
You put a dot in there.
You could, but that's not usually what we're going to do. Omari?
You do whatever the number is, and then you just do the. Okay.
What do you think, Ethan?
Rendering. Are we telling you why
No, because we're multiplying, not dividing. Derek? We're going to put parentheses, watch. Now can I tell those are two separate numbers?
Yeah.
Two separate numbers next to each other, side by side, with nothing in between means to do what? Means to multiply. Anybody want to raise your hand? I'm going to use a calculator. I'm going to ask, do you have a prediction about what this answer is going to be? Caleb, what's your prediction?
My prediction is $22 and 20 cents.
Peyton, what's your prediction? Same thing? Derek? Same thing? Let's see if you guys are right.
I know.
Here's 10 cents times 222. Watch what happens on here. Do you see that? This is what we get. That doesn't look like money, does it?
Yeah.
What?
Oh, yeah,
Raise your hands. You're not yelling at me from across the room. How can I make it look like money, Jason? I got to put a placeholder in the back. So the prediction was right. $22.20 is absolutely right. Here's the next question. Gavin needs $4.50 for returning cans. How many cans does he need? So this time, they're telling us the money. Look up here. They're telling us the money and wanting to know how many cans is that. So I'm going the opposite direction. I'm not going this way. I'm going this way. So I'm not going to multiply. What am I going to do? What's the opposite? Derek? We're going to divide. So watch this. I'm going to take the money and I'm going to divide by, and what was the number we were using? 10 cents, right? Now let me tell you, when you do this on your own, You have to put all the decimals in the right way, because otherwise when you get your answer, it won't be correct. So notice $4.50, there's a decimal there, and 10 cents, the decimal goes there. So let's see. Anybody want to estimate how many cans it's going to take? Kaden, what do you think?
45.
Anybody else have a different estimate? Caleb?
I have a, my estimate is yeah, times cans.
Okay, ready? $4.50 divided by 10 cents, 45 cans. Okay? How was D different than C? So let's look at D and C. What did we do up here, Peyton? And down here we did,
Divide.
right. So if you go one way, it's multiply. If you go the opposite way, it's divide. Does that still make sense? Okay, let's do one more together. The fare or the fee to ride a subway or a bus, $2.50 per ticket. So one ticket is going to cost $2.50. Does that make sense?
Yeah.
What about two tickets? Ethan?
3.
No, but that's a good guess. Jason? Nope, it's going to be $2.50 twice for two tickets. James?
$5.
There you go. What about three tickets? Anybody want to venture a guess on that, Dominic?
$7.50.
Do you see a pattern yet, guys? Look at this. Look at my list. You see it? $2.50, $5, $7.50, $10, $12.50, and we're going to stop there because then they start changing the numbers over here. So just go down the first 5. So one ticket, we're going to multiply every time by $2.50. So put those in. All the way down the whole table. We know if we go this way, from the small number to the big number, we're multiplying. Right? So who wants to guess, looking at what we've done already, any ideas, any estimates? You want to do an estimate on what you think it's going to be for 10 tickets? Brooklyn? 15 something? Anybody else? Ethan? $1.20? 10 tickets. One ticket's $2.50, so it's got to be way bigger than that. Maybe $20. What do you think, Kaden?
25.
What do you think, Peyton? 25, James?
25.
Derek, 25.
25.
25, Caleb?
26.
Okay, here we go. Let's do it. 10 times $2.50, $25. Now, let me show you these. Look at these two things and tell me if you see something. Look at the first row and then the one with the 10. What do you notice, Derek? We just added a 0 to here and we just added a 0 to here. Right? Right. So, look at these two numbers, 10 and 30, and tell me if you can give me a guess on what this one's going to be. Tyler. 75. Ethan, what do you say? 75. Caleb?
75 and 75 cents.
Brooklyn?
75.
Okay. Everybody want 75?
Yes. Yeah.
No? What do you say?
I would do 50.
Okay, let's try it. You ready? Here we go. 30 times $2.50. So watch this. Let me show you something. When you go from 10 to 30, that's times by 3, right? How about 3/4? 75 cents times by 3. Okay, so every time we go this direction, we times by 250. That makes sense? What am I going to write here? R 250. How do I write it, Derek? $2.50 R. The numbers first, the letters second. They're side by side with no X in between. If R is the number of rides, what's the expression? We just made it. We just did that, so that's what this answer is. Guys ready? Use this expression to figure out how much it would cost for 60 rides. So what do? I'm going to write down 250, and instead of R, I'm going to write down 60. See how I wrote them side by side? No X in between. You see that? So let's do the math and see what we come up with. $2.50 times 60. $150. Now what if we start out with the money and we want to know how many trips that is? So here's the money side. What if I start on this side and go that way? What am I going to do? Dominic? Divide by 3. So let's find the money. $175. Put your hand down. There's no question. You're trying to rush me. I got to go my speed. And then we want to know how many trips that is. So instead of times by 250, we're going to go divide by 250, right? You notice where the decimals are in there? If you wrote 175 divided by 250, you would not get the right answer. So you have to write both of them in dollars. $175, $2.50. There's no question, Caleb. So now we're going to divide and see what we get. You ready? $175 divided by $2.50. 70 rides.
I thought it was 300.
We're dividing. If you divide, you have to get a smaller number, right? So the first clue, guys, listen. The first clues you want to check is if you're dividing, your answer should be smaller. If you get a bigger answer, that should be like ding, 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 ding. Something's not right. Caden.
Since 10 equals 25, you also put 30 and put 10, which is 40, and add on another 30.
You could do it that way as well. Here's the next question. How is D different than C? Please raise your hand. What did we do in C and what did we do in D? Olivia? So we multiplied here and we divided by here. And how do you know which to do? Depends on which direction you go, right? So you got, am I going this way? Am I going this way? All right, we are going to skip the next page. Listen carefully to your directions. You guys ready? This is the problem set for lesson 20. Please put this in your book bag. We will complete the problem set together tomorrow. We're going to spend 2 days on this lesson. Let me talk to you while you guys are ready to hear me. Tomorrow's the last day of the marking period, so there are no more new assignments for tomorrow. We're going to finish that. Today, what I want you to know is that when we get back from spring break, we're going to start doing statistics and graphs. So, the purpose of today's IXL lesson is to give you a little bit of an introduction to what's coming next. Since I don't want to introduce a new lesson right now, This is just kind of a taste of, hey, this is kind of the stuff we're going to look at. So please log in there. Don't lose the highlighters I just handed out again today. This goes in your book bag. Oh, thank you.